Hello dear students, in this video we will see bond fission, or it is also called bond cleavage or bond breakage. And there are two kinds of an bond fission, one is homolytic and second one is heterolytic. So we will see this with an example. So like the video and subscribe the channel for more updates. Concept homolytic bond fission. Homo it means same and lytic it means breaking. So the bond it will break in a same manner on both the sides. Homolytic fission is also called hemolysis, and it is a type of bond fission that involves dissociation of an given molecule wherein one electron is retained by each of the original fragment of a molecule. Say suppose this A and B and B, it is a molecule and it is having a bond in between. Always remember that it may be a covalent bond, it may be an ionic bond, or it may be a dative bond. Always remember that when it is a bond, it is formed due to there are two electrons in between. So one electron it comes from A and one electron it comes from B in case of an covalent bond. If it is an ionic bond, so the electron pair will be coming from any one of the atom. So let us consider it is an covalent bond, that it is having shared from one A and one B, and this electron pair it forms a bond, and each bond it has only one pair of electron. Say suppose this A and B, now they will break, as here it says that dissociation of a molecule wherein one electron is retained by each original fragment of a molecule. So one will retain, and this arrow it is indicating that one electron it has been coming towards A and one it is going towards B, and this arrow it is a fishward arrow which is having only a half head. It is not having a double full head, because it is indicating that only one electron it has been transferring. When there are two electrons like here A and B, we will see in case of an hetero also, if totally electron pair it has been transferring on B, then it is shown by such kind of an arrow where it is having full head. So here it is only having an half head. Now once it dissociate, it will give A and plus one electron plus B, it will give one electron. So one electron it has been retained by each of the atom. Therefore, when a neutrally charged molecule is subjected to homolytic fission, two free radicals are obtained. So this A and B, it is a neutral molecule, and when they are subjected to an homolytic fission, we get a free radical. So this electron by a dot, it is indicating that it is a free radical. So there are two spaces, that is A and B, which are free radical, and one of each electron it has been written by A and one electron it is written by B. Say for an example, like chlorine molecule, so this Cl and Cl2 actually, when it has been subjected to an UV light, at that time it equally distributes an electron pair. So Cl it forms a free radical of one Cl and again a free radical of one Cl. So output of homolytic fission is that it gives a free radical only. Now we will see heterolytic bond fission. Heterolytic bond fission is such that in which covalent bond in between two chemical species, or we can say a molecule, is broken in unequal manner, resulting in a bond pair of electron being retained by one of an chemical species. So one it will be retained on one of an atom, and while the other species it becomes an electron deficient. So let us consider again an example, that is A and B. Say suppose there is a molecule that is A and there is B molecule. Suppose one it is electronegative and one will be an electropositive. So we will consider here that B it is more electronegative atom. and when there is breaking between bond between A and B, electron pair will be transferred on B. Always remember that it is an electron pair which will be transferring. A and B, they are formed due to sharing of electron, because here we have considered covalent bond, and one electron it comes from A and one electron it comes from B, and now B it is retaining an electron pair, while A it becomes an electron deficient. So like this is an example that A it becomes an positively charged and B it becomes a negatively charged. B, why it has a charge? Because electron pair as such, electron has a negative charge, and a pair of electron means one extra electron of an A it comes on B, and B it was already having its own electron, so that is why the charge on B it becomes a negative. For an example, like suppose if there are two carbons that will break, suppose say there are two carbons that will break, I will write here a carbon, and they breaks in an unequal manner, so I will transfer the electron pair on this carbon. So there are two electrons between one atom, and the output of it we get one of an carbon which is electron deficient and one carbon which is electron rich. So why we get an electron deficient and rich? Because a pair of electron it has been transferred on the carbon atom, so that is why we get this carbon having a negative charge where it is having an extra electron. But the carbon over here it has lose its electron towards the next carbon, and this kind of an carbons are said to be like so this carbon it is called carbocation. Cation, you might be knowing that it is having a positive charge, so remember that carbon having a positive charge is called said to be a carbocation, and second carbon which is having a negative charge is said to be a carbanion. Anion it has a negative charge and it is having a carbon. So there can be some different examples also, like suppose say we are having an example of an sodium chloride. So sodium and chloride it is having a bond in between. As you know that sodium it is a metal and chlorine it is a non-metal. So this bond when it breaks, a pair of electron it will always transfer on chlorine, as it is electronegative atom. So pair of electron it will transfer on an chlorine, and sodium it will become a positively charged, while chlorine it will become a negatively charged, as a pair of electron it has been transferred on Cl. So this it is a metal, and we get one more, that is non-metal. And there are some more outputs of this reaction, that if instead of an carbon, if there is an another species like it may be an chlorine, suppose I will write here chlorine. So instead of that I will write this chlorine. Chlorine will have only one valency of chlorine is only one, that is why it will have only one pair of electrons. Output of this it will be like I will rub this. Now definitely the lone pair of electron it will transfer on an chlorine, and the chlorine it will become a negatively charged, while in case of an carbon it will not retain electron pair and it will become an electron deficient. So here we generate it is said to be an electrophile and one is nucleophile. So nucleophile is such species that it retains an electron, while electrophile is such species that it is an electron deficient. So it is an electron deficient, while nucleophile it is electron rich. So this is the difference between heterolytic and homolytic fission. Thank you for watching the video. If you are having any doubts, you can comment me in the comment box. I will surely reply.